Hello and welcome. Today, we are diving deep into a process that happens silently inside millions of us. Atherosclerosis. It's the slow, sneaky culprit that hardens our arteries, and we're about to pull back the curtain and see exactly how it works. So let's kick things off with this really interesting quote about cholesterol. Implicated in several health complications and blamed I am for no fault of mine. It kind of frames cholesterol as this misunderstood character, right? So is it really the villain everyone makes it out to be, or is it just one piece of a much, much bigger puzzle? Let's figure that out. Here's how we're going to tackle this. First, we'll define what this silent artery clogger actually is. Then, we'll get into the good versus bad cholesterol. After that, we'll follow the trail of evidence, from the first sign of trouble, a fatty streak, all the way to a hardened plaque. We'll also look at the accomplices that speed up the damage, what happens when things go wrong, and, most importantly, how you can fight back. So let's jump in. Okay, first things first. What are we even talking about here? So picture your arteries as these amazing superhighways, right? They're busy delivering all the good stuff like oxygen and nutrients to every part of your body. Well, atherosclerosis is basically a massive slow-motion traffic jam that builds up on these highways, sometimes over decades. So to put a formal definition on it, atherosclerosis is when plaque, which is this nasty mix of fats, cells, and other gunk, builds up inside your artery walls. This buildup doesn't just sit there, it actually makes the arteries get thick and stiff. That narrows the road for blood to get through, and that's what ultimately sets the scene for some really serious problems like heart attacks and strokes. All right, now let's meet the key players in this whole drama. Because when it comes to cholesterol, it's not a one-size-fits-all situation. You've got your good guys, and you've definitely got your bad guys. And here they are, side by side. On the left, you've got LDL, or low-density lipoprotein. This is the infamous bad cholesterol. Think of it like a delivery service that drops off cholesterol packages throughout your body. The problem is, if there's too much of it, it starts leaving those packages in places they don't belong, like your artery walls. But then on the right, we have HDL, or high-density lipoprotein. This is the good cholesterol, and it's basically the recycling truck. It comes around, picks up all that excess cholesterol, and hauls it back to the liver to be disposed of. HDL is your friend here. It's protective. So how do we keep track of these guys in the real world? They're a simple blood test called a lipid profile. This table shows you the kind of numbers doctors look at. And really, the game plan is pretty straightforward. You want to keep your LDL, the bad guy, on the low side, and you want your HDL, the hero, to be as high as possible. And now, for the part you've been waiting for. How does a clean, healthy artery turn into a clogged one? Let's walk through the crime scene, step by step. Every crime needs an entry point, and in this case, it all starts with some kind of damage. The inner lining of your artery, it's called the endothelium, is supposed to be perfectly smooth. But things like high blood pressure or chemicals from smoking can rough it up, creating tiny injuries. This is the breach in the wall. The defense is down. Now that the barrier is broken, our bad guy, LDL, sees its chance. It sneaks past that damaged lining and gets into the artery wall itself. But here's where it gets even worse. Once inside, the LDL chemically changes. It gets oxidized. You can think of it like metal getting rusty. And this rusted LDL is way more dangerous. It basically sends out a red alert to your immune system. So your body's immune system sends in the troops. These cells, called macrophages, are like the cleanup crew. Their job is to gobble up all that toxic oxidized LDL. But they get completely overwhelmed. There's just too much of it. They eat and eat until they're so full of fat they transform into these things called foam cells. And these foam cells are the very first bricks in the wall of a plaque. As more and more of these foam cells pile up, they form what's called a fatty streak. But it doesn't stop there. Over the years, other cells and fibrous material join the party, building this streak into a hard, complex plaque. It ends up with a soft, fatty core and a tough, fibrous cap on top. And the whole time it's growing and slowly but surely narrowing that superhighway for your blood. So that's the fundamental process. But what makes it go from a slow burn to a raging fire? Well, let's talk about the accomplices, the risk factors that really speed things up. And here are the usual suspects. Now, these are called modifiable risk factors, which is actually good news. It means they're things we often have some control over. We've got dyslipidemia. That's just a fancy word for your cholesterol numbers being out of whack. Then there's high blood pressure,
diabetes, smoking, obesity, and not moving around enough. Each one of these is like throwing gasoline on the fire.
And you have to understand, these things don't act alone. They team up. It's a perfect storm. For instance, high blood pressure creates the initial damage to the artery, and high LDL provides the building blocks for the plaque that forms in that damaged spot. It's a truly dangerous combination. All of this brings us to the most critical part, the consequences. After years of silent buildup, what happens when one of these plaques finally becomes unstable? The moment of truth often happens when that tough, fibrous cap over the plaque breaks open. Now, if this happens in a coronary artery, one of the arteries feeding your heart muscle, your body panics. It thinks there's a major injury, so it does what it's programmed to do. It forms a blood clot to plug the hole. But remember, that artery is already narrowed, so this blood clot can easily become a total roadblock, completely cutting off blood flow to a part of the heart. The heart muscle is starved of oxygen, and it starts to die. That is a myocardial infarction, a heart attack. Okay, now let's replay that exact same chain of events, but this time it happens in a cerebral artery, one that's supplying blood to your brain. The plaque ruptures, the body, again, rushes to form a clot. And the result is a cerebrovascular accident, a stroke. It's the same mechanism, a sudden blockage from a blood clot, but this time it's brain tissue that's being deprived of oxygen and shutting down. That's all pretty scary stuff, I know, but here's the most important part of the whole story. What can we do about it? Let's wrap up by looking at how we can actually reclaim our arteries. Your first and best line of defense is always going to be lifestyle. Simple things can have a massive impact. A heart-healthy diet with good fats like PUFAs and plenty of fiber can help manage your cholesterol. Getting regular exercise, keeping your weight in a healthy range, and, this is a huge one, quitting smoking. These are incredibly powerful ways to stop the damage and maybe even reverse some of it. Then, of course, we have medical treatments. Statins are an absolute game changer. They work by going straight to the source, the liver, and blocking an enzyme that makes cholesterol. This just lowers your body's total LDL production. Then you have things like antiplatelet drugs, think aspirin, which make it harder for those dangerous blood clots to form in the first place. And obviously getting those accomplice conditions like high blood pressure and diabetes under control is absolutely essential.
So, when you boil it all down, your arteries are telling a story. It's a story written every single day by biochemistry and by the choices you make. So the final question isn't for me, it's for you. Now that you know how the story goes, what are you going to write in your next chapter?